Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
How John Bell's quantum revolution changed everything you know about reality. Did you know? Your phone, the emails you send, even the videos you watch, are all influenced by the work of one physicist, John Bell. Not only did he unravel the mysteries of the quantum world, but he also revolutionized the game of physics with a single theorem. You might be thinking, is this physics class, or am I watching a superhero movie? Trust me, Bell's story is far more captivating than any blockbuster. Quantum mechanics, just hearing that term probably makes you think of magic, right? Particles existing in two places at once, light passing through walls, time and space bending like rubber. Well, you're not alone in thinking it sounds like something out of a fantasy. The quantum world is like an ungraspable puzzle. And the key to this puzzle? John Bell. Before him, quantum mechanics was a mystery wrapped in equations and whiteboards, something that seemed too sci-fi to be applied in the real world. But Bell, with his almost magical reasoning, made everything clear, practical, and, dare I say, real. But wait, does quantum mechanics really sound like magic to you? If it weren't for Bell, this magic might still be locked away in the confines of the lab, completely out of reach. Today, we're going to reveal the secrets of this mysterious world and show you how Bell cut through the quantum veil, making it possible for us to explore this realm freely. Bell was born in Belfast, a small city that might seem ordinary, but its influence on Bell was far from it. His father was an electrical engineer, and his mother was a teacher. It's easy to see how Bell inherited his scientist DNA from them. Imagine being soaked in a science feast from a young age, except instead of playing with mud, Bell was more interested in electrical components and physics experiments. Maybe that's why his curiosity grew to be so sharp, constantly moving toward the world of quantum physics. Picture this: what if your parents told you electricity is magic when you were young? You'd probably become a little scientist yourself. For Bell, this scientist's DNA fermented quickly. From his family upbringing to his school education, everything led him down a path deeper and deeper into quantum physics. In college, Bell was like a shining new star in the field of physics. But don't think it was all smooth sailing. Quantum mechanics isn't a walk in the park, it's a huge, roaring beast that's not easy to tame. Bell struggled, too. Quantum theory is full of mystery, complexity, and deep concepts. It tested Bell's patience and his curiosity in ways that no other subject had before. But despite the early challenges, Bell eventually conquered this quantum beast thanks to his fearless curiosity. That's the kind of person he was, always up for a challenge. Even if quantum mechanics was as intimidating as a monster, he didn't hesitate to dive in and figure out its rules. As his academic career took off, Bell moved closer and closer to the heart of the physics world. After graduation, he went to Cambridge University for research, where he met many big names in the field. Guess what? At this point, Bell had no idea he would go on to challenge the very foundation of quantum mechanics. For him, being a regular researcher seemed like enough. But fate has a funny way of working. Instead of staying ordinary, Bell made a revolutionary move. He introduced Bell's theorem, completely reshaping the landscape of quantum mechanics. If you think this sounds like a scene straight out of a movie, you're not wrong. Bell went from being just another researcher at Cambridge to becoming a revolutionary in the quantum world. He had no idea that, years later, he would become one of the most controversial names in quantum physics history. Now, let's talk about quantum mechanics, a field that can make your brain feel like it's full of unbelievable ideas. You might ask, quantum mechanics? Isn't that the thing that made Einstein feel uncomfortable? Yes, it's exactly that. Einstein himself once said, "Quantum mechanics makes me feel uncomfortable." He even called it spooky action at a distance. Sound familiar? It's like a line from a science fiction movie, right? But don't worry, we're not going down a philosophical rabbit hole here. We're starting with Bell's theorem to show how the quantum world completely flipped the script in the physics community. Quantum mechanics, in itself, is like a black hole that pulls every physicist's mind into it. Imagine you have a particle that can exist in two places at once or even pass through walls. This isn't science fiction, it's just a Tuesday in the quantum world. It may seem absurd, but quantum mechanics has been repeatedly validated in experiments. So when Einstein encountered quantum mechanics, it was like opening a magical box that could change the world, but one that was hard to believe. Bell's arrival gave quantum mechanics a theorem-level explanation that made everything clear. Oh, so that's how it works. So, what did Bell actually do? Let's reveal how he cut through the quantum fog and paved the way with a lit path forward. The core of Bell's theorem is actually simple. If quantum mechanics is true, then certain experimental results cannot be explained by classical physics. It's like trying to measure something with a ruler, only to find that the ruler's scale has been twisted by the quantum world. You see, classical physics isn't that complicated. It's like using a normal ruler, and everything behaves predictably. But Bell found that the quantum world doesn't play by the rules. It's like using that ruler, and suddenly, the markings start to skew, and you realize quantum particles can be active in two places at once. That's when you realize quantum mechanics has quietly shifted the rules you've always known. Does this make your brain feel a little twisted? Don't worry, Bell's mathematical proof took this chaotic ruler and made it logical, finally helping everyone understand the quantum world doesn't follow the usual rules. Bell's proof sent shockwaves through the physics community. Think about it, who could argue that the old, reliable rules of classical physics could apply to this unruly quantum world? Bell's theorem wasn't just about providing a verifiable formula for quantum mechanics. It shattered the classical explanations of the time. Classical physics always believed that particle interactions were local, direct, and measurable. But Bell told us, look here, quantum mechanics says the world is non-local. Particles can interact instantaneously, even across distances. Remember Einstein's spooky action at a distance quote? When Bell's theorem came along, what was once magical in Einstein's eyes became real. What is quantum entanglement? It's like two particles being born connected. No matter how far apart they are, if one changes, the other immediately changes too. It's like a superpower in action. This is the insane charm of the quantum world, and Bell's theorem gave us this scientific miracle. You might think, this is crazy. Two particles can instantaneously affect each other across the universe. Yes, that's quantum entanglement. It sounds like something out of a sci-fi novel, but this is the truth that Bell's theorem revealed to us about the quantum world. Thanks to Bell's theorem, the quantum world went from an abstract theory to something quantifiable. It made scientists realize quantum mechanics is right, and the old classical ideas of locality and directness simply can't explain these non-local phenomena. You can think of Bell's theorem as the key to the quantum world. It broke open the old framework and opened up new ways of thinking. Bell's contribution wasn't just a mathematical proof, it was a vindication for quantum mechanics, helping us truly understand quantum entanglement, this phenomenon that's beyond imagination. Through Bell's theorem, we not only saw the absurd beauty of the quantum world, but also its profound impact on the real world. Behind all this was Bell's deep insight into quantum mechanics, which turned the field into one that could be experimentally verified and continuously developed. And now, we see more and more quantum technologies in our daily lives: quantum computing, quantum communication, even quantum encryption, all birthed under the guidance of Bell's theorem and steadily advancing toward maturity. In short, Bell's theorem was like a scientific bomb, blowing up the old rules of physics and pushing us into a new quantum world, one full of infinite possibilities. And guess what? These possibilities are just beginning to unfold. When you think about Bell's theorem, you've probably heard of the famous experiment by Alan Aspect, right? Back in 1982, Aspect and his team conducted a series of precise experiments that confirmed Bell's predictions, totally shattering the framework of classical physics. The quantum world? Turns out, it's really not what you thought. You're probably sitting there wondering, wait, how crazy is the quantum world, really? Here's a simple way to think about it: the quantum world is like your childhood fantasy land. Anything's possible, and nothing makes sense. Yeah, Aspect's experiment didn't just show us how wild the quantum world is, it gave us a big, bold OK stamp, proving that Bell's theorem isn't just something you write down on paper, it's real, it works in the lab too. Imagine this experiment as the ultimate power move of quantum physics. Aspect's team demonstrated the core of Bell's theorem using quantum entanglement, two particles, far apart, synchronizing instantly. Now, according to classical physics, everything is supposed to be local, independent, and calculated in an orderly manner. But quantum entanglement gave that idea a roundhouse kick. Particles can instantaneously affect each other across the universe, distance doesn't matter. This blew everyone's mind. It turns out, the quantum world is way more out there than we thought. Now, picture this: you and a friend on the other side of the planet both do the same thing at the same time, instantly. You send a signal, and boom, it's there in a split second. It's like you're both controlling the same remote, in perfect sync. Sounds like something out of a sci-fi flick, doesn't it? Well, even if you're not a fan of quantum mechanics, you've got to admit, quantum entanglement is a real-life superpower. This isn't just special effects from a movie, this is quantum mechanics in action. Today, quantum entanglement is at the heart of quantum communication. You send information to a friend faster than the speed of light? Nope, light speed's old news. Now we're talking about using quantum entanglement to send data farther and faster than ever before. So, the next time you send an email or hop on a video call, guess what? The data behind it might be powered by Bell's quantum entanglement, working its magic in the background. You've probably never realized that the magic of modern communication was actually predicted by Bell decades ago. Let's also talk about how Bell's theorem laid the groundwork for quantum information science, quantum computing, quantum communication, and even the future of the quantum internet. Can you imagine how fast the internet of the future could be? It won't be limited to the speed of traditional fiber optics, it could be instant connections powered by quantum entanglement. Remember when you dreamed about superfast internet as a kid? Well, this isn't just a fairy tale anymore, it might just be the quantum door Bell opened for us. Without Bell, quantum information science might still be a chapter in a sci-fi novel, but today, quantum technology is knocking on our door, ready to change everything. Quantum computing is now considered the next tech revolution. Quantum bits, or qubits, don't just flip between 0 and 1 like normal bits, they can switch between multiple states at lightning speed. Imagine solving a complex math problem. Traditional computers might take hours or even days, but quantum computers? Maybe just a few minutes. Sound like magic? Well, behind that magic is Bell's theorem, driving a tech leap like no other. Everything we can do today, the miracles in quantum tech, stems from Bell's theorem. It pulled back the curtain on the quantum world, and all those amazing technological achievements you're seeing today, they trace back to Bell's breakthrough. Quantum computing, quantum communication, and even quantum internet wouldn't be possible without the key that Bell provided. You could say that Bell's theorem is not just the king of all theorems in physics, but it's the path to the future of technology. Think of Bell's theorem as the key that opened the door to the quantum world. Today, quantum technology is changing every little detail of our lives, from more efficient computing to safer communication. The superpowers of the quantum world are slowly becoming a part of our everyday experience, and it's all thanks to Bell's pioneering work. Bell didn't just open up new realms in physics, he also gave us a blueprint for the future of technology. From quantum entanglement to quantum computing, his work shattered centuries-old scientific laws, allowing us to walk freely in the incredible world of quantum mechanics. So, Bell's experimental validation wasn't just an academic breakthrough, it directly impacted our tech lives, shrinking the once seemingly impossible gap between science and reality. You can think of today's quantum miracles as Bell's legacy: quantum communication, quantum internet, quantum computing, even quantum encryption. Bell's theorem is everywhere. Imagine the future of quantum networks: faster, more secure, and maybe even capable of doing things that seem like science fiction today. Without Bell, all of this might still be an unreachable dream. But now, thanks to his theory, we've got the direct path to the future. Bell's achievements are hard to ignore, but his personal life, it's actually more low-key than you'd think. His relationship with his wife, Molly Hill, is like the classic unsung hero story. You might think Molly was a quantum physics enthusiast or a die-hard fan of Einstein's theory of relativity, but she was just a regular woman who supported Bell's research and gave him the comfort of home in the busy academic life. They had 2 kids, and Bell, despite changing the face of quantum physics, was also your regular dad, strolling through the park with his kids, enjoying simple, quiet moments. Who would have thought the father of quantum physics was also a dedicated family man? You're probably curious about the personal side of someone who changed the world of physics. Bell's family life wasn't complicated by his scientific achievements. Unlike those scientists who almost disconnect from family life to focus only on their work, Bell was the opposite irregular father who didn't let his role as a quantum giant in the lab interfere with quality time at home. But Bell wasn't just a family man, he was also pretty funny. Believe it or not, the guy who changed the quantum world could also tell hilarious stories at parties. Apparently, he loved sharing quantum quirks with friends. Imagine him talking about quantum entanglement, while his friends are sitting there totally confused, thinking, "What in the world is this high-tech lingo?" And Bell, grinning from ear to ear, probably thinking, "Yeah, this is my quantum magic." Sometimes, while explaining quantum mechanics, Bell would throw in a humorous analogy to make science a little less highbrow. He might say, "These quantum particles are like you and your friend, never talking but always in perfect sync, like some weird relationship." His friends would laugh, and unknowingly, they'd come to understand quantum mechanics a little better. Who says physics has to be dry? Bell showed us that science can have humor, and sometimes, a bit of fun helps break down even the most complicated theories. And his humor wasn't just in words. Bell used quantum physics as the seasoning for his social interactions. At parties, when the conversation turned to something mundane, Bell would effortlessly steer it into the quantum world. He'd explain something totally unrelated using quantum mechanics, like why coffee doesn't stay hot for long or why we feel sleepy at night. With a chuckle, he'd say, "You know, that's actually quantum mechanics, particles doing illogical things, and that's why you're tired." You see, Bell wasn't just the big shot in quantum physics, he was the guy who made any gathering fun. For Bell, humor was like a quantum state, it could collapse into interesting conversations at any moment. Every time he talked about the quantum world, it was as if you could feel a deep quantum entanglement, leaving his listeners both confused and amazed, while Bell himself laughed like a kid, enjoying every moment of it. Bell didn't just make science fun, he made life around him filled with laughter. This unique sense of humor helped him stand out in academic circles and beyond. Science, humor, family, Bell successfully blended these seemingly unrelated elements into a persona that was both brilliant and approachable. If you thought Bell's life was all about endless lab work, you're way off. He wasn't just a quantum physics celebrity, he also knew how to enjoy life. Who would have guessed that a world-changing scientist could have a sense of humor that turns any gathering into a laughter-filled classroom? That's probably what makes Bell so special. Einstein's hidden variables theory suggested that behind all the supernatural phenomena of quantum mechanics, there must be some hidden variables at work. Only by finding these variables could we truly understand quantum mechanics. But then came Bell's theorem, and it directly challenged this view. Bell proved, mathematically, that if quantum mechanics is correct, then some experimental results simply cannot be explained by classical physics. In other words, Einstein's hidden variable theory? It had to be wrong. Yep, Bell's unassuming mathematical formula was like tossing an atomic bomb into the world of quantum physics, blasting apart the theories that many physicists had spent their careers defending. Though Einstein never acknowledged Bell's theorem as the cornerstone of quantum physics, one thing's for sure: Bell's theorem challenged Einstein's classical views and unlocked a whole new realm in quantum mechanics. You could say Bell's bold move essentially paved a highway for future scientists to explore areas like quantum entanglement and quantum computing without roadblocks. And while Einstein didn't win this academic showdown, his commitment to classical theory deeply influenced the development of quantum physics. The debate between Einstein and Bell wasn't just a clash of theories, it laid the groundwork for future breakthroughs in science. Bell's academic showdown wasn't some short-lived debate. It deeply reshaped the way physicists think and set the stage for the breakthroughs that would follow. Quantum mechanics was no longer just an abstract theory, it was now a science that could be experimentally tested and applied. Just imagine, without Bell's theorem, quantum communication and quantum computing might have been delayed by decades or maybe never realized at all. Bell didn't just give us a theorem, He gave physicists a breakthrough mindset that challenged old theories and accelerated the rapid growth of quantum technology. And here's the kicker: Bell didn't win the Nobel Prize, but that hasn't diminished his standing in the physics world. His achievements alone make him one of the founding figures in quantum physics, and even without those shiny awards, his influence has shaped generations of scientists. Today, countless quantum physicists continue to explore deeper realms of quantum mechanics based on Bell's work. You could say Bell's influence far surpasses any prize or accolade. It's become the bedrock of quantum physics. Bell's legacy is like that of a silent hero in academia. Unlike some scientists who bask in the spotlight of awards and applause, Bell's impact quietly grew in laboratories, taking root in every corner of quantum physics. And today, nearly every area of quantum research is deeply connected to Bell's theorem. From quantum communication to quantum computing and even the future of the quantum internet, Bell's influence still permeates the world of technology today. Even though Bell never chased a Nobel Prize, he didn't need that kind of recognition. He's already etched his name into the history of quantum physics. His theorem not only changed how we understand the world, but it also spurred deeper investigations into the quantum world. Whether it's quantum information science, the leap in quantum computing technology, or any number of advances in quantum tech, Bell's contributions are truly priceless. And when you use quantum computers to solve problems or rely on quantum encryption for secure communication, you may never know that Bell's name is silently pushing those technological advancements forward. If you still think Bell's theorem is just some theoretical mumbo-jumbo, think again. Bell's work didn't just advance quantum mechanics, it made quantum technology the real game-changer in the real world. Bell's influence goes far beyond any accolades. It laid the foundation for modern quantum technology and brought us closer to seeing the magic of quantum mechanics become reality. To sum it all up, John Bell wasn't just a behind-the-scenes player in quantum physics, he could very well be considered one of the founding fathers of modern quantum mechanics. His contributions are like the solid foundation upon which the entire world of physics stands. Imagine, if Bell hadn't come along, where would we be today? You might still be using an old rotary dial phone, waiting in line at a public phone booth just to make a call. Yeah, one of those where you had to spin the dial, took forever, right? Life would feel pretty far from the modern tech world we know today, wouldn't it? Bell's theorem didn't just help us understand the magical world of quantum mechanics, it made that magic a part of our everyday lives, changing the way we interact with the world. He proved that quantum entanglement, quantum computing, and quantum communication were not just science fiction, they were feasible and could change everything. So, Bell's work wasn't just a bunch of complicated formulas, it has made a tangible impact on our daily lives. Next time you pick up your phone and tap on the screen, take a moment to think about the person who brought us that quantum magic, John Bell. Without him, you might still be dealing with those old-fashioned phones, trying to stay in touch with friends while having no idea how the quantum world works. Without Bell's contributions, quantum communication, quantum computing, and even the quantum internet might still be stuck in the realm of theory. So, don't forget, behind all of this, there's a name you might not recognize: Bell. He opened a door to the world of technology, and behind that door is the boundless, mind-blowing realm of quantum mechanics.
The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.